Welcome back to another lesson in statistics. In this lesson, I am going to talk about what normal distribution is. Normal distribution is the most important distribution in statistics. Let's take a look at the picture on the upper left-hand corner. So remember this, remember what this is. You learned this in the introduction of statistics, right? We call that a histogram. So in histogram, what is the histogram for? The histogram is for us to look at the overall distribution. Distribution. What is distribution? The easiest way to explain distribution is how data spread out. Spread means distribution. Can we make that easy? I don't really understand how data spread out. What does that mean? What is really mean when you say data spread out? Just picture this in your mind. You grab a bunch of candies, okay? Use your both hands. Grab a bunch of candy, Skittles, whatever you like. Grab a bunch of candy. Grab as much as you can. Now, you have two hands, right? They are all filled up with candies. Now, drop all the candies on a table. What will happen? You see the candy will just fall all over the table, right? So the way they fall all over the place is distribution. So you have a table. You drop a bunch of candies on the table, and then you see how the candies spread out, right? So the way they spread out, the behavior is called distribution. So distribution means how things spread out. So in the first three histogram, we see a distribution. The first one is symmetrical. The second one is skewed left because the tail is on the left. The third one is skewed right because the tail is on the right. So what does that mean? When the distribution is symmetric, we have the mean, the median. They are all right in the middle. When the distribution is skewed left, what is skewed left mean? Skewed left means, let's say we have exam score. Most people are getting high score, but somehow we have a couple people, they got a very low score. So when you calculate the average, the low score students, they actually pull the mean to the left. So when the distribution is skewed left, the mean is being pulled to the left. When the distribution is skewed to the right, we have many low scores. However, these high scores, they make the average higher. So make the average higher means they pull the mean to the right. So again, for symmetrical, the first one, the mean, the median, they are all right in the middle. For skew left, the low score student, they pull the mean to the left. For skew right, the high score students, they pull the mean to the right. So what we are going to look at in this chapter is the first one, symmetrical. So we carry this histogram over here. I know they are not exactly the same, but they have the similar shape, right? So look at the yellow histogram right there. What is the distribution? The distribution is symmetric. We are no longer using bars. Today, we are going to use a graph to sketch the distribution. So if you take a look at the three graphs below the histogram, so this one, the green one, for symmetric distribution, you see a graph that looks like this, right? That looks like a mountain, like a hill. So this one, go back to the right. What do you see? This curve. This one is a bell curve. Why do we call this a bell curve? Because this curve looks like a bell. So the curve of normal distribution is similar to a bell. So this is the shape of a bell, right? So that's why we call this a bell curve. So every time when someone say, all right, normal distribution, what is the first thing that comes into your mind? The first thing that comes into your mind is a bell curve. So now let's do this. Let's do this. Normal distribution. I want you to pop one image in your mind. The bell curve, not the histogram, the bell curve. So before we move on to more introduction, I want to review 6 important vocabularies in statistics. Let's look at this table. So we have 2 columns, one for population and one for sample. So with the population mean, we have a Greek letter, we call this a mu. So it looks like a U, but we call this a mu. That is called a population mean, or you can call that a true mean. And then sigma square is a Greek letter that is population variance. Sigma, that is population standard deviation. They are for population. And then for sample, sample is taken from population, right? So sample is part of the population. We have to use some other symbol. So we use an X bar. So in statistic, every time you put a bar on top of a letter, we call that an average. The bar stands for average. And then sample variance, S square, sample standard deviation, the lowercase s. All right. So now, let's do this again. Normal distribution. What is the first thing that comes into your mind? Remember this? A bell curve, right? So when I say normal distribution, the bell curve comes into your mind. Now, that make you think about something. All right. So we just talked about uniform distribution last time. So let's use a different color for that. So uniform distribution. That is another type of distribution. So DIST for distribution. What do you have in there? A is the minimum and B is the maximum, right? And the probability density function, which means a function, is f of x equals to 1 divided by the maximum minus the minimum. That is the probability density function of uniform distribution. A is mean, B is max, X is a random variable. And then the graph looks like a histogram, a rectangle from A to B. This is the PDF, B1 divided by B minus C. We have this, remember, the area is equals to 1. The total area of the rectangle, the total area under the curve, not the curve, a straight line from here to there is 1. Well, then for normal distribution, we have another probability density function. What is the probability density function? So here is the probability density function. I'm going to go back to normal distribution. So we have a normal distribution probability density function. So that is f of x. X is a random variable. Now watch. 1 divided by sigma times the square root of 2 pi, and then e to the negative raised to a power, that is negative x minus mu square, divided by 2 times sigma square. That is the probability density function of normal distribution. What does that mean? That means if you graph this, what is the graph look like? The graph looks like a bell curve. So the graph of the super complicated function is a bell curve. And then what is x? X is a random variable. And then the sigma and the mu, they are called parameters. What is parameter? Parameter is the sigma and the mu. They control the shape of this bell curve. Where is the mu? The mu is the mean. Mean is right in the middle. And then the sigma describes the spread. So if you add 1 sigma to the right, and then 1 sigma to the left, so this is mu plus sigma, and then this mu minus sigma. The sigma is the spread of the bell curve. And then the mu is the center. Okay, mu is the center, sigma is the spread. They are called parameters. And then x is the random variable. What is the random variable? You go outside, you collect a number, that is x. All right, you go outside, you collect a number. So let's say x stands for score. You walk into a classroom, you collect a score for me, that is x. So x follows normal distribution, right? How do we write this? So this is how we write it. So we have x follows normal distribution with mean mu and standard deviation sigma. Again, x, this little curve stands for follows or is normally distributed with mean mu and standard deviation sigma. So in this curve, the bell curve, what else can we say? I have a cut right in the middle. Let me draw another one for you. So this bell curve, I have a cut right in the middle. What is the total area under the curve? The total area under the curve is 100, or 100%. So that means I have 50% on the left, 50% on the right. And by the way, this curve doesn't terminate in here and there. This curve extends all the way to the right and all the way to the left. So that means as the curve goes to the right, this as the curve goes to the right, this curve is approaching to the horizontal axis, but will not touch the horizontal axis. That means we still have area right there, but people usually don't draw it out. What are the characteristics of this bell curve? Then we have to take a look at this picture. So let's take a look at the yellow one, the one right here. So this one we have mu right in the middle. And then we have mu plus sigma, and then mu minus sigma, mu plus sigma, and mu minus sigma. So this is how you think. You have mu, you start right in the middle, plus or minus sigma. That means you take one step to the right and one step to the left. So that gives you some area right here. One step to the right, one step to the left, plus 2 sigma, minus 2 sigma. That means you take 2 steps to the right and 2 steps to the left. That gives you more area, right? So you have these 2 pieces plus these 2 pieces. So you actually get more area. If you add 3 sigma to the right and 3 sigma to the left, you get almost the entire curve. So you have, let me switch color. So you have, if you add 3 sigma, so you are taking 1, 2, 3 sigma to the right and 1, 2, 3 sigmas to the left. Does that cover the entire curve? The answer is no. So because of that, I have to introduce another important characteristics. But before we move on to that, let's explain all the words you see in this picture. So the first thing you see is the highest point of the curve is a downward cut. What is a downward cut? Downward cut means right here. So this is a downward, and then this one is upward, and then this one is upward. The upward and downward, think about this. Just think about the happy faces. So this one is a happy face, right? And then this one is a sad face, right? So happy face, do you see this mouth? This mouth, this curve is like a bowl. This is open upward, right? So this one is up, and then this one is down. So a happy face is facing up, a sad face is facing down. What about inflection point? Inflection point is where the up and down behavior changes. So from up to down, then this is an inflection. From down to up, and then this is an inflection. Do you really need these words in statistics? The answer is no, but the word is there. I will explain that anyway. So the highest point is easy. This is the tallest point of a mountain. What is the total area under this bell curve? The answer is 1. And then we have another picture above of that. So this picture links to a very important characteristic that is called empirical rule. What is empirical rule? Empirical rule has another name. It's called 68, 95, 99.7 rule. What does that mean? You start right in the middle, the middle, right in the middle, all right? So you take one step to the right and one step to the left, means you plus or minus 1 sigma. So when you plus or minus 1 sigma, you capture 68% of the area under the curve. So 34 plus 34 is 68. So if you take another step, 2 steps to the left and 2 steps to the right, that captures 95. 34 plus 34 plus 13.5 plus 13.5. The total is 95. If you take one more step, 3 sigmas to the left and 3 sigmas to the right, you have to include the yellow pieces too. So you add a 2.35, you add another 2.35. So now you have 99.7. So 99.7, we still have 0.3% left, right? Right, you still have 0.3% left, and then half of the 0.3% is on the right end, and then the other half is on the left end. I will try to not move the picture. The other half is on the left hand. So this orange piece is half of the 0.3%. So basically you have 0.30% divided by 2. So you have 15 on the left, 0.15 on the left, 0.15 on the right. So this is the empirical rule that helps you to estimate the area under the bell curve. But how come we don't use the base times height? Well, back to a uniform distribution, right there, you have a rectangle. What is the area of a rectangle? Base times height. Is the bell curve a rectangle? No. That's why base times height is no longer working. You have to use some other method to approximate the area under the curve. The base times height works for uniform distribution for this little rectangle only, not the belt. For the belt, there is some other way to calculate the area under the curve between one cut and another cut. And then we will get to that in this lesson. But before we get to that, I want to do more discussion of the mean and standard deviation. So do you still remember this? The mu and sigma, they are parameters. So what is that mean? You just said they changes the shape. All right. What shape? How? Can you show me a few examples? The few example is right here. So before we get into that, let me move this picture away. We move this picture away for something else. So now what we are going to do is we are trying to focus on this picture. Graph A, graph B, graph C. What do you see? I have three belts, right? A, B, and C. So for graph A, you have mean and standard deviation, 3.5 and 1.5. So the 3.5 is right in the middle. The 3.5 is right in the middle. And then the 1.5, 3.5 plus 1.5, 3.5 minus 1.5. So that gives you 68%, right? So the mu is actually the middle, the center of the belt. And then the sigma describes the spread. Okay, you say the spread is 1.5, then you take 1.5 step to the right and 1.5 to the left, then you get your 68%, right? So that is a bell curve. Let's take a look at B. So in B, we still have mean equals to 3.5. However, the standard deviation is 0.7. What is 0.7 for? All right, you have 3.5, you add 0.7, and then you minus 0.7, and then you get some area in the middle. How much is this area? The answer is 68%. Okay, compare A and B. The mu, no change. The sigma, one big, this one is big, this one is small, right? What happened if you change the sigma? The answer is if you change the sigma, then you change the spread. This is more spread out. And then this one is less spread out. What is more spread out? We call that example again. You have a bunch of candies, right, on your hand. You just drop all those candies on the table or on the floor. What happened? They just fall all over the place. So that means if the spread is big, the data will just fall all over the place. If the spread is small, the data, they are more concentrated in the middle. So that is the difference between small spread and big spread. Let's compare graph B and graph C. What do you see here? The mu, 3.5 and 1.5, the sigma, this time the sigma is no change. So the spreads are the same. That's why these two graphs, they are equally steep, right? This is pretty like tall mountain. They are both a tall mountain, right? What about the mu? 3.5 and 1.5. Notice the only thing they have changed is they change what? They change the center. So in conclusion, if you change the mu, then you shift the center. Of the belt. If you change the sigma, you change the spread. All right, so the mu is the center, is the middle. The spread is, well, if you change the spread, if the spread is large, then you get a shorter graph. If the spread is small, then you get a taller graph, right? So this one, if the spread is big, then you get a wide spread belt. If the spread is small, then you get a very steep and tall belt. So that's how we interpret the mean and standard deviation. Now, let's do some practice. So the first practice that I would like to do is I would like to do the sunshine radio. Let's take these pictures away. So I'm going to tap on this and then take that away because we need that for other discussions. Okay, we put the sunshine radio right there. Let's read the problem. The playing life of a sunshine radio is normally distributed with mean 600 hours. So mu is equals to 600 hours. And then standard deviation is equals to 100 hours. What is the probability that a radio selected at random will last from 600 to 700 hours? So we let x stands for a continuous random variable. All right. So it's x is the number of hours. And then in part A, probability, so 600, x, and then 700. How do we do that? Do we use the base times high? The answer is no, you don't do the base times high. So 600 and 700, how do you get 600? 600 is already the mu, right? So for 700, so 700 is actually equals to 600 plus 1 standard deviation. So what that means is, if you take a look at the graph, so here, we have the mean right in the middle. So if you add 1 standard deviation to the right, what is the probability? 34%. So this is 34%. That's how we do it. And then B is from 500 to 800. So B is probability 500x and then 800. So we have 600 from 6 to 5. So we have 600 minus 1 standard deviation. And then the 800 is that equals to 500, and then the 800, how do we go from 6 to 8? We have 600 and then we plus 2 standard deviation. So that equals to 800, right? So we take 1 step to the left and 2 steps to the right. So let's zoom in. We take 1 step to the left, so we take the 34 on the right and the 13.5. So 1 step, we take 1 number on the left and 2 numbers on the right. This is my center. So take 34 and 13.5. So we have a 34% plus 34% plus 13.5%. That is your answer. Okay. In part C, what is the probability that a radio selected at random will last at most 500? At most 500 means the maximum is 500. So probability then x is less than or equal to 500 hours. So how do you get the 500? The 500 is 600, right? Well, actually, I would, it's fine. So we have 600 minus 1 times the standard deviation. That equals to 500, right? But we are looking for less than 500. So less than 500 means, now we go back to the problem. So less than 500 is, we take, is right here, right? So less than 500 means you add the 13.5, the 2.35, and the 0.15. So you have 13.5% plus 2.35%, and then plus 0.15%. So that is your answer. And then the last one is at least. At least means 800 or above. So in part D, we have probability x greater than or equals to 800. Where is 800? So we have 600 plus 2 times standard deviation. That equals to 800. Greater than or equal to that. So we take a look. We take 2 steps to the right. So the cut is right here. And then we take everything above that. So we take the 2.35 and then the 0.15. So the answer to this is 2.35% and then plus 0.15%. So that equals to the answer. So that is how you answer the first question. The second question, I am going to bring this pictures over here. This thing, I will come back for it. Soft drinks. A vending machine automatically pours soft drink into cups. The amount of soft drink dispensed into a cup is normally distributed with a mean 7.6, so mu is equals to 7.6, and then standard deviation is equals to 0.4. Estimate the probability that the machine will overflow an 8-ounce cup. What is overflow? Overflow, the cup capacity is 8. To overflow the cup, you have to put more than 8 ounces of drinks to it, right? So in part A, we have probability x greater than 8. How do we get 8? 8 is 7.6, and then you add 1 standard deviation to the right, so you get an 8, right? So let me take that picture, because I'm going to take the big one. I'm going to copy that, and then paste that over here. Okay, doesn't allow me to do that. Try that again. Copy. Paste. It works. All right. 8 greater than 8, so we take 1 step to the right, 1 step to the right, and then we add the rest, right? So 1 step to the right, we are right here, and then we add the rest, so that is 13.5 plus 2.35, and then plus 0.15%. That is your answer. And then B is not overflow, that is probability x less than or equal to 8. Less than or equal to 8. So what is the area? Less than or equal to 8. This is your 8, right? So less than or equal to 8, that means you take everything on the left. So that is 34% plus 34%, that is 68, and then plus 13.5 plus 2.35, and then plus 0.15%. So that is your answer. And then the last one is a machine has been loaded with 850 cups. How many of these do you expect to overflow? What does that mean? You need to find the probability of overflow. And then you take the probability and then multiply the 850, right? So that means we have to calculate the answer for part A. We have 13.5 plus 2.35 plus 0.15. That equals to 16%. And then for part C, the probability of overflow is 16%. And then you have 850 cups. So that means you take 850 cups times 0.16. What is that equal to? 850 times 0.16. So that is around 136 cups. That is how you answer these questions. Now, what is X? X is a continuous random variable that follows normal distribution. And then this mu is the mean is the center. And then sigma is the spread. All right. Can we bring more discussions to this? Yes. First, let me go ahead and grab a picture. So let me go ahead and grab this. I'm going to copy that. And then they don't let me paste. I will just bring it all the way down. That works too. Okay, now I have 2 classes. So let's say I have a morning class and an afternoon class. Jet is in my morning class. Tina is in my afternoon class. I gave the same exams to my morning class and my afternoon class. Now, in these 2 classes, they have a different average and a sigma. So in the morning class, we have mu equals to 72. The spread is 25. In the afternoon class, I have the mean 64. and the sigma is 5. Take a look at their score. Jack got 82 points on the test and Tina got 74 points on the test. My question is, who did better on the test? 82 and 74. Now, to make a comparison, you don't just compare 82 and 74. You have to compare your score to everybody in the class. Who did better in their class? How do we compare? Well, 82 is equals to 72 plus 25. 74 is equals to oh, actually, no. I was doing this too fast. No. They are both 10 points above the average, right? So 72 plus 10 equals to 82. And then 64 plus 10 equals to 74. They are both 10 points above the average. How do I know which person is better? Now, to make such comparison, here is what I am going to do. We are going to do one comparison, one for Jack and then one for Tina. For Jack, I am going to take Jack's score, 82. I am going to subtract the average and then divide it by 25. And then from Tina, I am going to take 74 minus 64 divided by 5. So this is a 10 divided by 5 that equals to 2. This is 10 divided by 25. Let's quickly 10 divided by 25. That is equals to 0.4. What is 2 mean and what is 0.4 mean? Okay, here is how we explain the 2 and the 0.4. First, they have a name. We call them the standardized score. Standardized score is not a raw score. The 74 and the 82, they are raw scores. Standardized score means you have to subtract the mean and then divide it by the sigma. So 0.4 means Jack is 0.4 standard deviation above average. And then Tina is 2 standard deviation above average. That's how you explain the 0.4 and the 2. 0.4 standard deviation above average and 2 standard deviation above average. So overall, the conclusion is who performed better on the test? The answer is Tina, because she is 2 standard deviation above average, which is way better than Jack. So if you just take a look at the picture, although they are both 10 points above average, this is more spread out, right? This one is less spread out. Less spread out means the graph is taller. So if the graph is taller and you are 10 points above average, the standard deviation is small, is 5. If you are 10 points above average, you are right there. This person is 10 points above average, is there. Where is the highest score? The highest score must be the person on the right hand side and is so far away from the mean. Think about this. The class average is 72. You got perfect score on the test. You are definitely right here, right? The class average is 64. You got perfect score on the test. You are definitely right there. You are way better than everybody else. What if you're on the left side? If you're on the left side, that is a bad news. That means your score is almost the lowest score in the entire class. All right, so look, this is 74, is closer to the right end. The 82 is less closer to the right end. So of course, based on this comparison, we say that Tina did a better job on this test, although they are both 10 points above average. So that is how we consider the mean and standard deviation, and that is how we compare one score to the entire class. All right, you don't compare your score with your friend. You compare your score with the entire class, And then that is how we do it. So I remember that there is a picture that we missed. All right, so this is the picture that we missed. So let me bring all the way to the next page, and then we take a look what is in here. So we have standard normal distribution. The mean of standard normal distribution is 0. The standard deviation of standard normal distribution is 1. So for standard normal, the mu is equals to 0. The sigma is equals to 1. I want you to remember this. For standard normal, the mean is 0. The standard deviation is 1. Why do we need to do this? Because when the mu is 0, the standard deviation is 1. I am talking about always 0 and 1. What happened when you change the mean and the standard deviation? If you change the mean, what happened? The center will just shift left and right. If you change the sigma, you change the spread. Now, we are not changing anything. The mu stays the same, the sigma stays the same. So when they stay the same, that means we are not changing the spread of this graph. So look how simple the number is. The mean is 0. The standard deviation is 1. So 0 plus or minus 1 plus or minus 2 times 1 plus or minus 3 times 1. So that means we are not changing the graph. We are not changing the shape of this graph. Why do we doing this? Because it is easier to take care of the area under the graph. Standard normal, right? So think about this. If you are talking about, let's say, a pretty standard midterm, right? So what is the mean and standard deviation usually be? So let's just make an example. So the mean is 80 points. The standard deviation is 10 points, right? So let's say we use some other numbers. Well, let's say we talk about the height of buildings in the downtown area. Well, the mu can be like, I don't know, can be like 300 feet. The standard deviation can be like 50 feet. So sometimes the mu and sigma are big, sometimes they are small. The purpose of doing standard normal is I want to take an observation, subtract the mean, divided by sigma, and then that equals to a standardized score. So this is how we standardize. Z equals to x minus mu divided by sigma. You take an observation, subtract the mean, divided by sigma, you get a z. And then for the z, you can tell is the standard deviation above or below, is the observation above or below the mean. If that is above, how much above? If that is below, how much below? And that is how we standardize numbers. So let's say we have an example. So let's say on a test, the mean is 80, the standard deviation is equals to 10. Let's say someone got 65 points on the test. Someone got 65 points on the test. Can you make a comparison for me? Yes, this is how we compare. We have z, not x. We have z equals to 65 minus 80 divided by 10, that equals to negative 1.5. I'm not saying that this person got negative points on the test. I am saying that this student is 1.5 standard deviation below average. Like if you just look at this and the 65, can you tell that this person is how do you say this? Compare 65 and a 90. How do you compare this? Well, do you compare 65 and 80 and then 65 and 10? You don't do that. You do a z. So z, you do a standardization for me. You take the observation, subtract the mean, divided by sigma. So for 90, you take z equals to 90 minus 80 divided by 10. That is 10 divided by 10, that equals to 1. 90 point means the person is 1 standard deviation above average. So negative z means below average. Positive z means above average. But sometimes people got exactly what the average is, right? So let's say my score is 80. Then z is equals to 80 80 minus 80 divided by 10, that is equal to 0. I didn't get a 0 on the test. My standardized score is 0. That means I am exactly on average. Again, how do you standardize a number? So z equals to x minus mu divided by sigma. That is how you standardize. So after you standardize, you don't have to take care of the big mu, the small sigma, or those kind of things. You only need to know one thing. Z means standard normal. In standard normal distribution, the mean is equals to 0. Sigma is equals to 1. So we are not changing the center. We are not changing the shape. Everything is fixed. Fixed like what? Fixed like this. Everything is fixed just like this. 0 and 1. So no more big numbers. Oh, what about the unit? There is no unit. Z is a Z. A number is a number. You don't have a number followed by a unit because that is the standardized value. All right. In the next lesson, I will show you how to calculate the area under this bell curve. This is not a rectangle. So to calculate the area, we need some technique, and you will have to use a graphing calculator to do it. All right. I see you all in the next lesson.